group number 8 presentation for data mining project for the subject Big Data. I'm Angel and my team members are Kunal and Bhargav. We are presenting our project for data mining for online grocery shopping. We chose this project because nowadays e-commerce has become a part of the everyday life. Um, Here we have the question what to mine and why. Well, as you see, database of a grocery store is what you're gonna be mining. What we are trying to aim during this project is to predict the placement of products in the store, perform market basket analysis using a priori algorithm. Uh, Companies like Amazon have started grocery shopping online, so it has become the need of our to implement data mining for such a target market. In order to perform data mining, we select a dataset after reviewing thoroughly a large number of them by keeping into consideration the consistency and the interoperability of the tables of the dataset. The dataset select was from resiswiki.com. This dataset is of a grocery market. As we can see in this slide, we're gonna be showing the tables customer, product, and transaction. Those are like our main table. As of them, we create more tables applying data mining. Here we're gonna show the customer one. As you can see, some of the attributes, because it's having a lot of, are customer ID, account number, the name, address, and many other. As well, we can find the table products. This table has basically the product class ID, the product ID, brand name. It has many other attributes. And finally, representing this one, that is the transaction, we can open either of them. So we're gonna show this one where you can see that we can bind both tables. So that is going to be like way easier for us to do any query or anything. Now we are showing the graphics about this is like the raw data without being mining or anything. Here we haven't applied not even the mm, the nominal. We haven't applied nominal yet. So I mean after these slides, you're gonna see how this data is being transformed. What we're gonna do now is basically just to show how we are loading the dataset. As you see, we transform this SQL to CSV because this is the way that Weka works. See, here we are loading the data. Still, we haven't applied any filter. After this, my partner is going to be applying numeric to nominal and as well as the algorithm and so on. That's it.
My name is Bhargav and I would like to continue the presentation from here. Now that we have the original data loaded, we need to find out if there is any association or any knowledge that is hidden within the original data. To do that, we need to perform data mining on this data. However, there are many noisy data, many values in the data which makes it very noisy, and there are many attributes which we do not require while we are performing the mining. For that, we cleanse the data. In order to clean the data, we use SQL queries so that we have only those selected attributes and the relationship between them which we require for the association. For the same, we apply the SQL queries. First, we try to find out if there is a relationship between the customer and the promotion. For that, we use the following query and find out a table if there is a relationship between the promotion and the customer. This is where the cleaning is applied. Now, we run this query and we find out if there is any relationship. So this is the new table that is obtained: promotion ID, customer ID, product ID, and the time ID. So for a given time, whether the given customer buys a product, the promotion ID is valid or not. Now The next query we use to clean the data is the relationship between the promotion and the time. So for that, we cleanse the data and run the following query so that we get a new table. This is the new table which has the things to do with the promotion ID and the time of the year, whether it is a customer purchases a particular product.
I'm Kunal Sawant and I'm going to continue the topic of cleansing of data. Now we'll be running the following query. In this table, we try to find out the relationship between the customer ID, product ID, the promotion ID, and also the month in which the transaction has taken place. And now we run the another query. In this, we try to find out the relationship between a customer and his yearly income and his product, as well as the number of children at home and his education. Now the next step in cleansing is pre-processing, in which we convert the data from numeric to nominal so that we can use the associate rule. So we add the table to this, and now we apply the numeric to nominal on it, so that now the data is read as nominal and not as numerical. The next step, we go to associate, and we use a priori algorithm, in which we have chosen the minimum confidence to be 0.7, and these are the four attributes on which a priori will try to find the relationship. So we have found two rules in which we have found the relationship between the promo ID and the customer. Here we have found out that for a particular promo ID, a particular customer does buy a product. So from this we can conclude that for what promotion IDs we can target a particular customers, and with a really high confidence of 1 as well as 0.91.
Now we start the data mining on the another file which has product ID and customer ID, and so we open that file. And now we perform numerical to nominal change, and then we apply that. This is the nominal value that is updated. As you can see that we have different ranges of income and the number of people in that range. Now we apply the a priori algorithm, and with this we get the association rules between the yearly income, number of children, education, and the products that they purchase. So the a priori is the Veka is performing the a priori algorithm, and it is getting loaded. Now there are 10 set of rules which have been found out for this cleansed data and this table. The first rule states that whenever the income of a person is between 30 to 50k $1,000, and they have completed partial education, and when they buy a 5689 product, then they usually have zero number of children, and they also purchase a product 5497. Apart from that, whenever the income is between 30 to 50k, and when they purchase the product 10564, they usually have zero children, and they also purchase product 9366. If the number of children are zero and education is partial college, they also, and if they purchase 6228, usually their income is 30k to 50k, and they purchase product 5497. These all have a very high confidence, that is above 0.85. Now, whenever the education of a or the fourth rule states that the education, if it is in partial college and they purchase 7404 the product ID, they usually have 0 children, and they also purchase 6228 product ID. When the education is high school and they purchase 5378 the product, the number of children is equal to 0, and they have also purchased product 4540. Apart from that, if the education is partial college and when they purchase 7404, the yearly income is usually between 30K to 50K, and their confidence is of point 0.8, and they usually purchase product number 5689 as well. Now, the next rule states that if the number of children are 0 and they go to high school, when they have purchased product 4540, they have an income of 30K to 50K, and they also purchase the product 3312. So these are all the association rules that we get by applying our by applying association on the cleansed data using Weka. So these are our results.
This is Angel once again. The basic project that we are working on is to try to deploy a database system, a web server, and a cloud computer platform in order to host the first two. The database system implementation will be used based on MySQL. In this case, we're planning to use MySQL Community Server, since the license is GLP, is enough and is for free. As well, we could be using Workbench if you want to visualize the design and so on. Right now, this is the web page. As you see, basically it has the range of the salary, the products that those people use to work more frequently. For example, if I click in the range 10 to 30, is going to show those products. For the web page, we will be using the technology of JSP, that is basically like Java for web. As well, for the connection between the database and the web page, we will be using JDBC driver, which work perfectly with MySQL using the connector J. To host the web page, well, as you see, all of them are working. To host the web page, we rent a service in Amazon, and in this case we opt to rent the EC2 one. Now I'm just going to access to the server just to show that. Well, basically this is the server. Just for example, right now we're gonna show that Tomcat is running properly. Well, I have to log out as a root, but well, basically this is the part of the part of showing the web page. We won't spend more time on that because this is not this wasn't the project. This is just like an extra that we were trying to add in order to show like in a graphic way what we were working on. I think that this is our project. Any doubt could be left as a comment. Thank you.
Mined the data, and we have found various association rules between the production, promotion ID, customer, time, etc. We would like to and also we explained the application of the mined data, how we'll be using it, probably by showing that the people with for particular income range usually buy such products and so on. And also I would like to add that since nowadays Amazon and other websites are trying to do grocery shopping online, and Amazon has started selling vegetables and stuff online in certain regions, so this will be very much useful for performing data mining in such areas. And we would like to conclude by thanking you all for watching this video, and feel free to post questions on the comments. Thank you.